There are very good reasons why we have different styles and types of control valves. With each of the valve styles, there are multiple variations. The goal is to select the proper product to reliably satisfy the application requirements. In order to select that product, we need to have an easily understood method for doing this that can be easily applied and get consistent results. Just because I have a flow coefficient doesn't mean I'm going to successfully select the best control valve. So what other considerations need to be taken into account? Lifecycle considerations such as initial capital expense versus installed equipment life expectancy should be taken into account. If you have an installation that's expected to last for the duration of your process, you should consider spending more money to get the set it and forget it type of control valve. However, if it's a short-term installation that's only going to be around for a couple of months, you may consider a more economical option. Maintenance schedule. Are there going to be routine shutdowns, and if so, what are the frequencies? The location of the valve needs to be considered too. Is the valve close to the ground where it's easily accessible? Or is it up on a scaffold where you have to rent a crane in order to remove it for maintenance? And then, how much does it cost to maintain? The downtime that is incurred when a valve is out of service is lost revenue. Also, look at the valve's impact on a process, its availability and reliability. How close to set point does that control valve need to operate? Is 10% acceptable, or does it need to be 1% or even 0.5% accurate? You also need to consider code requirements such as B16.34 and any industry-specific regulations. There are material requirements such as NACE or ISO for corrosion resistance, and then there also may be specific application site and project requirements that also need to be taken into consideration. Other things to keep in mind are no two applications are identical. Even a company that has multiple facilities that are, quote, exactly the same, or just one facility with duplicate trains, no two processes are completely identical. There's going to be something different. Maybe the piping is slightly skewed. Maybe you have fluctuations in temperature and pressure. Even though one valve installation is successful, that success may not be duplicated in an identical train. All these things need to be considered, and, unfortunately, the desires of the engineering piping contractor and the end user will sometimes be contradictory. What happens if you don't select the ideal control valve assembly? This first picture, you can see the set point, and you can watch the valve trying to operate at the same point, but it is jumping all over the place. Poor control can lead to wasted feedstock, as well as off-spec product. Also, if you don't consider all the metallurgical aspects that are going on inside that valve, you can have stress corrosion cracking and trim failures that are unexpected. In the final example, we have a globe valve with what appears to be a trim inspection hole. However, that's not the case. This void is actually the result of a corrosion coupled with erosion that occurred from flow acceleration. You had a fluid going through a carbon steel control valve that was impinging upon the inside of the valve body. Rust that formed inside the valve body and was continuously getting wiped away and eventually created a hole in the wall. Needless to say, control valve performance is a critical factor in achieving operational excellence. Visit Fisher.com or contact your local Emerson sales office to learn more.